Hi, this is Skill 27 Notes with Ms. Claywell, solving log equations. So we've talked about logs, but we have not talked about this idea of common logs and natural logs. So if we have log base 10 to x, that's the same as just a log x. So just we assume that there's an invisible 10 there. So if I saw log 10 of 100 equals x, that is the same as log base 10 of 100 equals x. So in other words, 10 to what power equals 100? We would know that's 2. So this is called a common log. If we don't have a base, we assume, if there's not a visible base, we assume the base is 10. There's something called a natural log. If we have e, that's the same as ln of x. So if we see ln 3 equals x, this is the same as log base e of 3 equals x. In other words, e to the x equals 3. We aren't going to take a second to solve that for x. I'm just showing us what that means. So e and ln cancel each other out. So if I wanted to solve for x here, I would take each side to the e power. This e and this ln would cancel each other out, and I'd be left with x equals e to the 8. Now, when we think of calculators, common logs and natural logs are the only logs that are in our calculators. So when you look at your calculator, if you typed in log 100, it equals 2. We are assuming that the calculator, when it just has a log, it's assuming an invisible 10 there. Your calculator also has ln of 4. If you want to find that and practice typing that in, that's 1.386. Okay, we're going to move on to solve an equation with a log on one side of the equation. You use the following steps. We rewrite the equation, we isolate the log expression to one side, convert to exponential, then we check for extraneous solutions. So that means any solution that would make a log negative is bad and we can't use it. So knowing that, in those steps, we're going to go ahead and start the next two problems. So my first step here is I want to isolate my log then I want to convert to standard or to exponential form. If it helps you, we can rewrite it with a loop. And remember, log or ln of x is the same as log base e. So saying e to the 9th equals x. In other words, x equals 8,130.84. Similar situation here. Remember, I want to isolate my log. And there's a base 10. If I loop that, I get 10 to the negative 2 equals 10x. You can solve this a couple different ways. Or think of it, this is 0.01. (0.001) equals x. If I look at letter or example C, I can loop it as it is. 5 to the 20th equals x to the 4th. In other words, this is going to be a really big number. I'm not going to try to say it. I can take everything to get rid of that 4th. I can take everything to the 4th power. (3,125) is what equals x. My last one, I still want to rewrite it in exponential form. Then I can loop it. This is saying e to the 8 equals x. And this is how we work with problems that have x on one side of the equation, or a log on one side of the equation. So sometimes we'll see problems with logs on both sides of the equation. If the logs on both sides are the same, then we can set the insides equal to each other, and we may have to condense it to one log on both sides before we can solve. So this is also reviewing our properties from last time. So I'm going to go ahead and start with something like example B. Because my logs are the same, log base 5, log is 5, I can go ahead and just set the insides equal. This is kind of like the idea that we can set our exponents equal. So what equals negative 20 but adds to positive 1 would be a positive 5 and a negative 4. So I'd have x equals -5 and +4. And then if I think about it, if I put a 5, I'd still come out with a positive log, and if I put in a 4, I'd come out with a positive log. So both of those work. I don't have any extraneous solutions. If I look at A, I do not have condensed logs. So I want to condense the log on the left, right? Remember, subtraction is division. Here I can cross multiply, or whichever way you think of it. I miscopied, so I made a mistake. This is going to be 5 times x minus 4, so this is going to be a plus 20 minus 20. Equals 10. X equals 6. And if I think about my extraneous solutions, if I plug a 6 where I see an x, I'd have no negative input. Our last two examples both have condensing and factoring. So this is multiplying, so this becomes log x times x minus 3 equals log base 28. Remember, once I have one log on both sides, I can set my inputs equal. What multiplies to -28 but adds to my -3 would be -7 and 4. So we still need to be really comfortable with factor by grouping. Now I need to check both of those. That would be a -4. If I put in a 7, that works. It doesn't cause anything to be negative. If I put in -4, it would cause both of these logs to be negative, so this would be extraneous. We have one more problem. It has to do with E. I can condense these. I made a mistake here in how I wrote that. So that'd be x5 minus x. So 5x minus x squared equals 6. So this goes back to just like being really comfortable with factoring. So 3 and 2, neither of those would cause me to divide by a negative log. So both of those are potential answers.